Well, hello there. My name is Romance Cheesit, and today I'm going to explain all you need to know about grammars and languages for the upcoming final. So, when we talk about languages in computer science, we're talking about languages that are actually modeled off of real life languages. Linguists created a model, a formal model, and we took that model and tried to create our own languages that abstracted from a machine code, because machine code is really hard for humans to read. So we put in a way that humans might be able to understand a little better. There are four terms that you need to know for to be able to understand and parse through syntax, or parse through and understand languages in computer science. We need to understand what a sentence is. You need to understand what a language is, and what a lexeme is, and what a token is. These are really easy terms to understand. So a sentence is just a string of characters over some alphabet, right? So think of the English alphabet: A, B, C, D, E, F, G, A, on and on. There's 26 letters in in the English alphabet. Any combination of those letters that forms a word is considered, and any string of those words is considered a sentence. A language is just the set of all those possible sentences. That is quite infinite in English, but it's a set of all those sentences that are valid in the language per its grammar. We'll get to that in a second. A lexeme is the lowest level syntactical unit of a language. So these would be equivalent to words in English. Like if I was to say "I love you," the words "I love" and "you" would be the lexemes. Actually, I might as well just go ahead and write that down as an example. So if I put "I love you," these are your lexemes. And the token, finally, is a category of lexemes. So, right here, this is a pronoun, as we know. This is a verb, and this is another pronoun, right? But we could say something like "I love cats," dogs. It could be nouns, adjectives, adverbs, adjunctions, conjunctions, prepositions. There's a whole load of different types of lexemes. So that's basically the basics as to what it is in how computer science languages kind of relate back to our language, our natural languages. So the first thing that a grammar, just like English grammar, there are rules in English grammar, and that grammar provides a framework for creating valid sentences. And it also, at the same time, simultaneously provides a framework for recognizing valid sentences, right? So whenever someone says something that's grammatically incorrect to you, you recognize it as grammatically incorrect because you know the grammar, you know the rules, if that makes any sense. And you use those rules to be able, sorry, I hit my glasses, but you use those rules to be able to generate sentences for other people to understand. So, think of it like reading and writing. Generators write, recognizers read. There are two ways to be able, sorry about that, but there are two ways to be able to understand or describe syntax, to describe grammar. So English grammar is not really, a lot of people have tried to make books compiling what is correct English grammar, and that's kind of, think of it like a book about grammar, but instead of someone just listing down all the instead of someone trying to explain the rules, give examples, etc., it's just a list of rules, and those rules are strictly held to. They are extremely consistent, and they don't vary from region to region. So that's basically what computer science rules are like. For example, there are two ways of being able to describe this syntax. You have the BNF form and CFG, and then you have the extended BNF. So BNF and extended BNF, we really only are going to go over BNF and extended BNF. And so the next thing we're going to do, there are some grammars that are so simple, like Regex Expressions. We don't really need to know much about that, but they're so simple, they have such simple rules that regular expressions are not really considered in the same, even though they do make languages and they do strings can be used to be, they can define languages and strings can be generated from them. They aren't really considered part or important enough to be described by BNFs. If I go down here, okay, so BNFs are really simple to understand. So each line, so this is an example of a BNF, right? So each line has a rule. So this is, sorry, this is a rule. This is another rule. And each rule has a non-terminal. This is called a non-terminal. And the reason why it's called non-terminal is because it can be described by something that's not a constant, right? And they have a terminal, like this, which cannot be described by anything. It's the lowest unit. You can't go any further than that. And non-terminals are described by either terminals or not, either all terminals or non-terminal and a terminal. So, or just non-terminal. So those are this is the simplest part of it. The next important part that you need to know is that this sign means or. This is an or. If you've coded anywhere, anytime before, you should know that that bar is an or. And then you should also know that these symbols here are actually, they're literals. They're string literals. So if say this is expression is a term plus a term, whatever this term is plus, literally plus that term. So just, we'll see an example of that in the later video, but that's just a good kind of introduction into what they are. So in the next video, we're going to actually go by and use this BNF to be able to derive a sentence, and we'll generate a sentence and recognize that sentence and then create a parse tree from that sentence. So thanks for watching.